Okay, so just hang in there with the radius stuff, and as we do a little bit more, hopefully you'll become more familiar with it, and it'll be less painful. So let's look at number 2. Just set up the integral that can be used to find volume. So we're not going to work this one all the way out. We're just going to set it up. Okay, you will be given y equals x squared plus 1, x equals 0, x equals 2, y equals 0, and told to revolve about x equals 3. This information I graphed. You can use your graphing calculator. You can make an XY table. I just did this to save time. And the first thing I'm going to do is I'm going to draw my axis of revolution, sketch this thing out, and my mindset is I'm going to find my axis of revolution. It's right here, x equals 3. Because it's shell method, I want my representative rectangle to be parallel to that. So that automatically denotes for us that this is going to be a dx. That means all of our variables are going to be in terms of x. And what about our intervals? In terms of x. Good. So that's kind of our mindset. Now, radius, we just practiced on this radius. My radius is actually from here to here is what my radius needs to be. So if from here to here is x, and here to here, actually I'll draw it. So if, what is the distance from here to here is 3, right? And we said our x is the distance from here to here. So our radius is just going to be this black portion, which we'll just say 3 minus x. Okay. Next, the altitude would be the height of this thing, which is just basically where it touches that function, right? So of our rectangle, which is just represented by the x squared plus 1. Okay, now we can put this in, so volume is equal to, if I bring the 2 pi out front, that's optional, you can choose to do that or not. Now what about our, we need x values here, so what's it look like it's going from? 0 to 2, right? 0 to 2. Our radius, this x represents your radius, so what is our radius? 3 minus x, good. And what is our f of x? Our altitude or our height, x squared plus 1 dx. Now for this particular example, we were just asked to set it up. If we were to actually calculate this, we would just multiply this out and then proceed with the fundamental theorem of calculus. So, all right, let's do the same thing with number 3. Of course, this one's going to be, we're going to deal with the dy region. But first of all, just recall, you're going to be given y equals the square root of x, y equals 0, x equals 4, and they tell you your axis of revolution. Now, after I sketch all these and get my rough sketch, which is just basically the blue, the orange, and the green, and the purple, I need to make note of my axis of revolution. So first thing I do is I see this, I remind myself I'm working with shell method, so I need parallel to the axis of revolution. So that tells me I'm going to be working with the dy region. My thickness is dy. Okay, since it's dy, my volume will be represented in terms of y values. And what about this AB, or sometimes in the textbook we let it be CD just so it distinguishes the difference. It really doesn't matter, but what do these need to be in terms of the Y values? Good. Okay, so let's actually I'll pause it for a second and let you try the radius and see if you can take this as far as you can go, and then we'll check our answer. Okay, so let's work with this radius. First of all, we know the radius is from here to here. But previously, when we worked on that, we were working with the x. So this time we have a y. So from here to here, we would just say let be y. Okay, well then what's the distance from here to here? 2. So what would you tell me about our radius? 2 minus y. Good. Okay. That's not too bad. Now the altitude, I cheated over here and I kind of turned this up because altitude's high. So if we were able to just visually turn our head right here, we can see that the height of this thing, it's much easier to see if I flipped it, right? Nice for nice little visual help there. What would our this from here to here is 4, right? All the way across. So basically, if I would did it on here, from here to here is 4 units, and it would subtract out. Whoops, not right there. We need to subtract out our function. So we're just going to have, let me write it in red. This would be 4 minus, what is our function in terms of y? Y squared. Now, what we did up here is we changed this, solved this for x equals because everything's in terms of dy. So remember, we had to change all of our variables over and solve this for x equals, which I did that already in your image, and maybe I should have mentioned that, reminded you about that before we got to this part. But so this is just going to be, the height would be 4 minus y squared. Okay. And now I want you to go ahead and plug that in. And we would have volume is equal to, let's pull our 2 pi out. What about our intervals? Remember, we're working with our y values. 0 to 2. Good. We put out our 2 pi. What was our y? Y represents our radius. It's just going to be 2 minus y. Our f of y is our altitude, so it's going to be 4 minus y squared dy. Okay, that one was a little bit challenging in respect to there was changes on both of these. All right, so the next example we're going to look at is we're given two graphs. Okay, we're given y equals x squared plus 4x, which is the blue, and y equals 2x, which is the purple. So go ahead, you would take your time, graph those out. We want to take special note of revolving about the y-axis. So the first thing I'm going to do is make my revolve about the y-axis. That means if I'm using shell method, my representative rectangle is going to be parallel to that. So I label that thing dx. So also, how can we get these ordered pair points up here? How do we know where these two intersect? You could set them equal to each other. So y equals 2x, x squared minus 4, and solve that. We've done that plenty of times, so you can do your intersections or you can use your calculator to find intersection points. Okay, now let's work on our radius. If this is our x, our radius from here to here is just x. So let's just draw that in. This is going to be radius is x. Okay, and so I also had a question if the radius is just x because it's revolved around the y-axis. Now let's say I had it revolved around a different radius, then we would have to account for that. But in this case, if it's just the y-axis or the x-axis, it's going to be just our basic radius. So from here to here is just x. Now the altitude, what about altitude here? It's a little bit difference because from here to here, I'm just going to let that be, I'm just going to say, let's let that be y1. Okay, what would the height of that be represented by? This purple graph, which is which function? What, y equals 2x? Good. Now I also have this part, this height here, which also we want to keep in mind, it's below the x-axis. So the way I would get the height of that is if I had 0 and subtracted out this function. That would just be, let me call that y2 just for the sake of it. That would be 0 minus my blue function, which is x squared minus 4x. So let me just simplify that. So actually, this needs to have a parenthesis around it. 0 minus that entire function. So 0 minus the blue, which one then just gives us negative, distribute that negative out. and that would give us x squared plus 4x. Okay, so it's just that negative wasn't supposed to be there, so it's negative x squared plus 4x. So our altitude, our height, so what would we do with these two to get height? Add them together. So I'm going to represent that over here. So the y1, so this is from here to here is 2x, and then from here to here is just going to be that negative x squared plus 4x. Now let's simplify that, and that is just negative x squared plus 6x. Alright, so we had to do a little bit of work on our altitude. It wasn't just quite as basic as the previous one. Let's set up our integral. So I'm going to pull the 2 pi out. If this is dx, x, what are our x values? Here. Okay, so from 0 to 6, remember you can do intersect, so you set these two equal to each other, do that work on the side, or you can use your graphing calculator to find intersection points. Just make sure if all these are in terms of x, your intervals are in terms of x, and then we have our radius is x, and our altitude is negative x squared plus 6x, and our thickness is dx. Okay, we're going to take this on the next page. I'll carry this over and we're going to actually do the calculation. Okay, and so this is just what we carried over. We algebraically simplified and then calculated the rest of this. So check your work.